Hello everyone, let's try to solve few more questions which are from JEE Advanced 2023 PVQs from paper 1. I have already solved few questions in my previous video. I'll give the link in the description box, and I hope these videos will be helpful for your JEE Advanced 2025 preparation. So yeah, let's start the video. I don't want to waste your time. Yes, let's read the question. In the following reactions, P, Q, R and S are the major products. So we need to find overall PQRS, and we need to uh, find the correct statements about these products. All right. So we need to solve these conversions. These are very simple. I'll explain you. Here the first reaction will be what? CH3, CH2, CH, CH3. You can write it in a bond line form, which is easy. But yeah, okay. So the reagent is this Grignard reagent, PHMGBr, and then they have given hydrolysis, right? So what will happen? This the pH minus phenyl, this act as a nucleophile, and it will attack on this carbon, and this one of the bond shift towards nitrogen, and it will form this. Here, imine formation takes place generally. C double bond N. So let me draw it with the bond line form. This is the methyl group on third carbon, and yeah, this is CH2. All right, CH2, and this will be C double bond and MgBr. This is negative and this is positive. Here we have pH. All right, this is actually imine formation, imine salt, or you can say anything. Yeah, you can watch this video in 2x speed because it can save you time, or else just 1.5x. Yeah. Then after they have given hydrolysis also, right? So what will happen? Just break this bond, add oxygen over here and H2 over here first. Upon hydrolysis, we'll get the ketone. Alright? Here we'll get this product. C double bond O pH. So we have got this product, and then again one more mole of this Grignard reagent they have given. So what will happen here? Again, this pH minus will attack over on this carbon, and we'll get the alcohol. All right, tertiary alcohol. Let me write it over here with another one. Yeah. So let me write it over here only. It will be clear for you. pH MgBr, right? This will attack on this carbonyl carbon, and then this bond shift towards here, and then what we'll get here? CO negative, and here pH will get, and here already one phenyl group is there. And upon hydrolysis, I'm just writing it over here itself. We'll get this OH. So this is the final product, which is P, right? And you can see they are talking about asymmetric carbon and symmetric carbon. Let me tell you what is asymmetric carbon. Asymmetric carbon means the carbon should contain four different groups, which is chiral carbon, you can say. Asymmetric means this one, like carbon atoms should contain four different groups. We can call it as chiral carbon, right? That is asymmetric carbon. So is there any carbon which is asymmetric here? Yeah, you can see. I'll just highlight it. See here, this carbon is asymmetric, right? This one. Here, this carbon is attached to this ethyl, methyl, and one hydrogen, and this group, right? So one asymmetric carbon is there. So for product P, it has asymmetric carbon. All right. So options will be in A, C, and D. They have mentioned P has asymmetric carbon. So one of the answer might correct. Yeah, this is the multiple answer question. So you can see here they have mentioned is or so many options can be correct. So one of the conversion we have solved. Let me just solve another conversions. They have given this. They have given this benzene. pH H means it is benzene only, and here and as we know that this is what Friedel-Crafts acylation. Sorry, this is in the presence of anhydrous AlCl3. All right. This is Fieldcraft acylation. First, what will it will form? This two will react and we'll get this selenium ion or this group CH3 C double bond O positive, and then after that, what will happen? Electrophilic aromatic substitution occurs, and here I'm not going. Should I explain you the mechanism? What will happen? Nothing. Just this one of the bond shift towards here. It will form this negative positive, right? If you just shift like this, and this negative will attack over here on this carbon, and then deprotonation occurs, then it will regain its aromaticity. But it's just simple mechanism. So I'm writing it directly. I hope you know how to write the product, right? After doing paragraph acylation, simple C double bond O CH3. This is electrophilic aromatic substitution. This is an electrophile and it is getting substituted on the aromatic ring. So that's why it is electrophilic substitution, aromatic substitution. Sorry. Yeah. Then after what will happen? Another reagent what they have given. Another reagent this again they have given the nitrogen pH MgBr, and then after they have given hydrolysis, and again here it will act like a nucleophile and it will attack on this carbonyl carbon. Then this bond shift towards here and then it will protonate in the presence of hydrolysis. Then we'll get this type of product COH. Here we have pH, right? pH CH3. So this is the product, and you can see here there is no chiral carbon, right? So this is an asymmetric carbon. Sorry, I mean it doesn't contain any asymmetric carbon. So this is the product Q, which doesn't contain any asymmetric carbons. But here they have mentioned Q have asymmetric carbon, so this option will be wrong. And here also they have mentioned this word asymmetric carbon, so this is also wrong. So these two options we have eliminated, right? So let's try to solve this particular third conversion. Here they have given this CH3 CH2 C double bond O Cl, and in the presence of this is a type of organocadmium catalyst, and it is also similar to the Grignard reagent. This benzyl group act like a nucleophile CH2 negative. This act like a nucleophile and it will attack on this carbonyl carbon, and this chlorine will be leaved as a living group, and then we will get this thing CH3 CH2 C double bond O CH2 pH. All right, we'll get this. And then again, they have given Grignard reagent, CHMgBr. And then again, after that, they have given hydrolysis. What will happen? You know this thing, right? It will attack on this carbonyl carbon, this shift towards here. And then in the next process, hydrolysis, this substrates one of the hydrogen. And finally, we'll get this thing, CH3, CH2, COH. Here it is pH, CH2, pH. All right. Final product is this. Yeah? So here you can see this carbon. Let me highlight here. So this carbon is a asymmetric carbon, which is a chiral carbon, right? Which contains four different groups. Here this is ethyl OH, pH, and this is benzyl group CH2PH. So if this compound R also has, it also has a asymmetric carbon. So you can say P and both P and R have asymmetric carbons. This option is true, and we need to check the option D also. For that, we need to solve for S. So let's last one, and which is pH CH2 C double bond OH, right? And again, the same thing. You just need to know how this mechanism works. I mean, how to play with this Grignard reagent and all, right? And what will happen here? Same thing, this act like a nucleophile and it will attack on this carbonyl carbon. And here we will get this pH, CH2. And also they have mentioned hydrolysis. So this will abstract the hydrogen afterwards and then we'll get this OH here, H, pH. Alright. Then the next reagent what they have given, CrO3 dilute H2SO4. This is the Jones reagent. CrO3 dilute H2SO4, which is a Jones reagent, which is a strong oxidizing agent. What it will do, this is a secondary alcohol, right? It converts secondary alcohol into ketone, right? So we'll get here this. It converts this secondary alcohol to ketone, CH2, C double bond O, pH. We'll get this one. And the next reagent, what they have given, HCN. It is just simply nucleophilic substitution. Here this Cn negative acts like a nucleophile and it will attack on this carbon. And this bond shift towards here, and this one abstract this hydrogen, and finally we'll get this cyanohydrate CH2 COH CH, and this will be Cl. And the next reagent they have given H2SO4 and heat. If you in the presence of like this is like a hydrolysis only, right? In the presence of acidic medium, what it will do, it will convert this cyanide group into acidic group. So we'll get this CH2COH. This will convert to acidic group COH, and this is the pH. And now again they have mentioned heat also. So just don't neglect here this thing. And here what will happen? Dehydration takes place. One of the hydrogen from here and this OH from here will be removed, and here the bond formation takes place. Let me write it here. CH double bond C. Here it will be pH, and here it will be COH. So you can see there is no chiral carbon or asymmetric carbon here. So you can say that this option is also correct. P has asymmetric carbon and S doesn't have any asymmetric carbon. So option C and D will be the correct answer for this particular question. So it's see, only simple thing we have did here. You just need to know how this reactions, I mean, how can we do with the Grignard reagent? That's it. It is just simply like it acts like a nucleophile and it will attack on the carbonyl carbon, which is having partial positive charge, right? And this simple stuff you just need to know, all right? This is a simple question, and you need to have an idea what exactly the asymmetric carbon. And yeah, of course, you people are preparing for JEE Advanced Mains. That thing, these are the basic thing you know, right? So yeah, you can check the answer over here. I have given. You can just recheck it as if you want. Let's solve one more question. Yeah, this is also easy one. And here they have given in the given reaction scheme. P is a phenyl alkyl ether and Q is aromatic compound. R and S are the major products. So they have given. We need to find correct statement regarding S. So it will be here aspirin, and in order to answer this question, you have to read NCRT. They have given exactly the same sentence from the NCRT regarding that aspirin. So if you read, then only you'll answer this question. See, you might solve this conversion, but if you don't know anything about aspirin, how can you able to answer? That is a waste of time, right? So that's what I can't help you regarding this good, because you need to read at least once that NCRT. Yeah, for organic chemistry NCRT might not be enough for reactions and all, but for theory type you can just read it once, and I can help you how these reactions are occurring, and this can I can explain you, but for theory I can't do anything, so you just have to help yourself by reading it. All right, yeah, let's solve this. These phenyl alkyl ether means what? This is the phenyl group, and this R means here I'm taking R can be any alkyl group. They didn't mention anything specifically. They have mentioned alkyl only, so we can just take it like this. And this in the presence of HI means this is the cleavage of ethers. This is the famous reaction, right? So what will happen in the first step? Protonation occurs. This oxygen has lone pair side. This will abstract the hydrogen and it will form this OH positive R. And then afterwards, what will happen? Like I negative, this act like a nucleophile, and here there are two choices. See, here it can attack on the alkyl group, or else it can attack on the phenyl group. But here it won't attack on the phenyl group, because there is a here a lone pair will be there on oxygen, right? So these due to the partial double bond character between the phenyl group and oxygen, it won't attack on this. Due to the resonance here, we are getting partial double bond character. So this will attack on this alkyl group and this bond shift towards oxygen. So here finally we'll get here this phenol plus, right. And the next one, this is the aromatic. They have already mentioned Q. We need to take aromatic compound. This is not an aromatic compound, so this will be the Q. All right, and then let me just change the color. Yeah, and then we have got the Q, and the next one they have given what is the this these are the reagents which we will use for cold-based reaction, right? This is exactly the name reaction they have given. This is cold-based reaction. So here we'll get salicylic acid, salicylic or salicylic, whatever you can say. Yeah, we'll get this OH, COH. And the next step, so this is the product R. And in the next step, sorry, in the next step, it is an anhydride, right? So what will happen? Let me write it as CH3, C double bond O, O, C double bond O, CH3. So here what we can, let me just write it over here. It will be easy to understand for the people. What we have got here, this is this salicylic acid, right? OH, and here we have the C double bond OH. And then they have given this acetic anhydride CH3, C double bond O, O, C double bond O, CH. For your understanding, I am just writing it here like this. So what will happen means here there are two possibilities. One is this oxygen can participate in this, like this will attack on this carbonyl carbon, or else this one will attack on this. But here this carbon is this oxygen alone by itself participating in the resonance with this carbonyl carbon, right? So these are little busy. So these are free. So it will attack. It will attack on this carbonyl carbon and will get this thing. Oxygen, it will become positive, and it, like this will be like, you can just write like this directly. This whole group will be lived as a living group, and here we'll get C double bond O CH3, and here the COH will be like this only. Then again deprotonation occurs, and this hydrogen will be lived. Finally we'll get this aspirin, OAC COH. So as we know that this is aspirin. Sorry for the writing like this. Yeah, I don't have here. There's no space, but yeah, you have got it. This is aspirin, right? I'm writing it here again. OAC, and here it is CO. This is aspirin, and as we know that aspirin is a non-narcotic drug, so this option we can eliminate it. See, this aspirin is not an orthoacetyl benzoic acid. It is an orthoacetoxy, because here we have OC double bond OCH3. This is acetoxy group. So it is an orthoacetoxy benzoic acid. So this option is also wrong. And then in CRT textbook, they have clearly mentioned that this it inhibits the synthesis of something, whatever, what is this, prostaglandin, whatever it is. Yeah, you have to read. I can't help you with this. Yeah, this exact sentence they have mentioned in the NCRT. So yeah, you have to read it once. So option B is the correct answer. I hope you have understood this question also. And yeah, these videos, I hope these videos are helping you people. Only one motivation behind doing all these things. See, it also take time for me to create these videos and edit and all, right? So because I just wanted to help you people. I know before exam solving previous year questions is the best thing that we can do, but mostly in YouTube, you might get so many videos, but yeah, if my videos also, the way I'm explaining, if you like the way I'm explaining, if you connect with this, and if you can able to understand it easily, then that will be good, right? So I hope few people, I hope these videos will be helpful for you. And yeah, I'm not going to ask for you to subscribe and all, but yeah, you can do that if you think that these videos are helping you in any way. All right, because that gives some sort of motivation to me, for me to do all these things, right? Yeah, that's it. Take care, and just don't take that much tension. I can say this, but I know in what type of situation you people are there, exam stress and all. But see, preparing for exam is only there in your hand. So just do that. I mean, I can say anything I want, but you people have to do that. See, JEE Advanced, it's just not about preparation and all. It's about your mindset also, how you are maintaining that positive attitude. That is really matters. I can just take care of yourself and just remember I'm always there with you people whenever you feel low or something. If you have any doubt, just let me know in the comment section. I would really love to help you people in this journey. So take care and yeah, bye.